I think it's time to start our report out session. So, today kind of the idea was we had a keynote and we had the talks, but kind of we had this breakout session, which was, it was not as much about like specific research. It was more about getting a bit more high level picture of what the research should be about, in particular, what the future project should be about. And also like just to get to know people and see who might be kind of resonating with us on this kind of the right wavelengths to hopefully follow up on. But now it might be useful since we had, like we had this, in my session, we had a very good discussion. It might be good to spend some time by having the colleagues for, for both sessions, just summarize what the discussion was about, some interesting lessons learned and so on. So, who wants to start?
All right, I can start, I guess.
Yeah.
So my session was relatively sparsely attended and very much MIT biased. So the attendees were myself, Holly Wong, a grad student who was taking notes, Stephanie Jigulka, Tamara Broderick, Ankur Moitra, Martin Renard, Arvind, and Evelyn Viegas. So as you can see, a very heavy MIT bias, relatively small Microsoft representation, which was a little disappointing to me. It was an interesting, if certainly unfocused discussion. Kind of went all over the place. We talked about the difficulties of data collection, and the general notion that what many people call real data isn't actually real data. There's what I would call very little real data, say in the UCI collection of data sets, yet people claim that's the real data for their experiments. We talked about the fact that it's not representative of what happens when you actually try and collect data. We did, of course, as we were supposed to, talk about bias. And one of the things that was an interesting point was that in many ways, the scientific process seems to be broken with machine learning research. And maybe more generally research. And we saw that in the two recent COVID-19 papers that were withdrawn from Lancet and New England Journal of Medicine, that healthcare data typically comes with restrictions on who can look at it. And because of those restrictions, we can carefully review lots of details about the analysis, but it's very hard to know whether the data itself is biased or sensible or useful. And especially increasingly, we're seeing data sets that are being put together by private for-profit companies. And the question is, how do we go about balancing privacy concerns, proprietary concerns, with our ability to have any confidence in whether we should believe the models when we have no access to the data. And that seems to be a problem that is bad and growing worse. And nobody had a good solution in that, Eric and I work with data from hospitals, and if we were told we couldn't publish papers using those data because those data are not available to anyone who wants to look at it, then we couldn't publish papers. And then we're back to publishing only papers on toy data sets, which would also be bad. So there was a general issue there about how to walk that line and what it does to the scientific process. And I don't think there were any good answers about that, but it was certainly an issue that we had a good discussion about, I think. A lot of discussion. Go ahead, someone wanted to say something? No, okay. Since we were, a lot of us interested in healthcare, we were talking about aids for clinical decision making, and the whole issues of whether models should be believed, and then trying to understand separately whether you trust the model as a whole versus trusting a particular prediction, and understanding that those are two very different things. That you might think on aggregate the model is pretty good and still think a particular prediction is bad. And so there was a lot of interest in, partly got tied up in issues of giving error bounds on models, error bounds on predictions, and whether those would actually make sense, say, to a clinician trying to make a decision. Did they really want to do that? And this had to do with, particularly as the models get ever more complex, and the trade-off between transparency and accuracy. That we can build more accurate models, but it's frequently at the cost of them being less transparent as to what they're actually doing. And there were unfortunately no clinicians on the call. They were all machine learning folks. So those of us who interact with clinicians could only relay secondhand what they tell us. But my view is we put less emphasis on transparency than maybe we should, and more emphasis on accuracy than maybe we should. There was a discussion about, related to that is transparency about the training data, and how do you know whether or not, when you're making a prediction for an individual patient or person, whether that person is well represented in the training data or not. And that was a complicated thing, and we talked about, well, if you had simple models like nearest neighbors, and you were making prediction and saying, well, because here are what the neighbors look like, then a clinician could say, no, that's actually not what this person looks like, and reject the prediction. But that isn't so good when there are 1,000 features that we're dealing with. How do we say what the neighbors looks like? And in general, then the question came up of how many models should you build? This is something that I know Eric and I have done research on together, on generalizable model building versus generalizable models. And a big question, and particularly this relates to bias in data and things like that, is how do you do that? And so there was one view, well, you can use clinical experts to say, well, men and women are different, and therefore I don't believe a model that's trained on both. And then it gets a little more complicated when you say that Asian Americans are different from Americans in aggregate, or different from Asians in Asia, and how do you do that? And what kind of techniques can we use from a technical perspective to try and identify subgroups for whom we should build separable models? All right, so I think I've probably used up my allotted time, so I will stop there.
Okay, thanks, John. Yes, and who would have thought that having 6 or 7 MIT faculty, this discussion would be a bit disorganized? That's totally not total shock.
Just absolutely shocked.
Yes. So essentially, I just want to mention something that just gives us. So this is something that I was talking a little bit to Evelyn and Eric, is that Microsoft actually has this open data initiative, where they have an intention of publishing, open sourcing the data sets that grew out around the collaboration between MSR researchers and someone outside. And I definitely think that there is a much more leadership and effort needed here in terms of making more data available. I think this is, the industry has data, but it's a closely guarded, quantity, and it would be really nice if, if moving forward, we could also change something on this in this dimension. But yeah, and now I will, it's time for us to hear from the other session.
I guess on our end, we had a discussion. Andrew, do you want to go? Where are you going?
No, I was going to say that Puya was going to present the notes that he took.
It's actually fine with me. If you want, you can present it. It's okay.
I mean, Puya, you can go. Go ahead.
Yeah, go ahead.
So there were quite a lot of people talking about AI safety in the other discussion, and the range of topics that people talked about, the range of problems and solutions was so vast that I'm a little bit worried that I might have missed something. So if I have, just feel free to complete what I'm saying.
Yeah, but the good news, John, is we were very organized. Just kidding.
So initially there was this talk about detecting safety. And well, if it can be detected, then maybe designing a system that takes over your AI, takes the control out of the AI and just steers it back to safe regions where, this can somehow solve the problem of AI doing things that you don't generally see when it's being trained. But there might be problems where it might be too late when it's unsafe. And so like one of the solutions that people discussed is maybe you should predict what you're going to do, when you're going to do it, maybe predict when you're going to be unsafe. And if you can define safety, then that might be something worth working on. There was also another talk about if machines are making mistakes similar to humans, that might be enough because like we're comparing them with humans. But on the other hand, there was another talk about maybe we should make the machine intelligence and natural human intelligence distinct and look at them differently and expect different things from them, because like an AI might have a different behavior from a human, and that might be okay because that might be actually a better approach, and we shouldn't expect all AIs to behave like us. And there was also another talk about the fear of AI systems that are trained individually and then deployed in a system where there are actually multiple AI agents. And a talk about an example of a stock market crash incident that happened a few years back. I think I remember there was a 5 to 10% decrease in stock value. And that was actually because of AIs that were trained individually. But then they were deployed in the setting where there were other companies using AIs too, and that actually led to the incident. There was actually another high-level overlook, which I think was similar things to what we're seeing in the other discussion. It was about what can we do as researchers from here on out that might make this problem less significant. There was this general concern that you are rewarded more when you bring a new idea than just making an old idea work or evaluating an old idea or analyzing problems with an old idea. That's like something inherent to how researchers are working. And this is actually something that people should do. Like on the one hand, researchers that are bringing some idea, they should also bring analysis on when will it come short? What are going to be the problems with it? How can you attack it? And maybe even there were ideas about maybe even bringing in logs about exactly what these researchers went through, the different phases that they went through and stuff like that, and actually making that log open to the public. But there was also another proposal that about like red teams that are seen in the industry that just aim to break a system. That's their goal, and they're highly rewarded for that. But like there were also concerns that this red team proposal might not work in the academic community, because like AI solutions right now are probably very easily breakable, and that's nothing weird about it. Like if it's broken, that's something that we expect. But then again, it might be worthwhile to know exactly when it will break. And there was finally this idea of creating benchmarks that actually target the safety, which would kind of be a method to evaluate all ideas equally and very extensively, like seeing raw performance along with safety as well. That's a rough explanation of everything that went on. I'm pretty sure that I probably missed something out. Feel free to say anything that's not in there.
Well, just to add a little bit for the urgency of some of the discussion topics, and also do an intersection with some of the things that came out of the first working group, the other working group for John's summary, is this idea of most of the world of consumers, like the national security and DoD and corporate world, want to take models built with data potentially and reuse them all over the place with minor tweaks. And there's some good work on generalization to different distributional settings, but we're nowhere near as good as with doing that as the consumers of the technology want or believe right now. And so there's a real urgency to getting the news out about this, and also coming up with best practices when it comes to using a machine learned pattern recognizer in an application or classifier when we know how easy it is to shift distributions away from the training and validation and test environments in a real world scenario. And so what is the whole process by which we need to sort of, for education, but as well as fielding the technologies, what is the process by which we require certification and tracking and even identification of a setting for which a system was not trained to operate in robustly? Or are there robust methods that would allow fast tuning and reuse, even in non-adversarial situations, of course, talking about to start with. So I did mention I'm on a committee that's actually looking for recommendations right now to Congress and for R&D as well as for standards. That's giving me heartburn even being on the committee. What do you tell, what should Congress require, for example? When it comes up with new laws and legislation about national security applications of machine learning. That's a little bit of extra frosting.
Yes. Yeah. So thank you. Thank you. And again, the idea here is that like it's a little bit always depressing for me that we kind of paint the problems and then we don't have a solution. But I think there is like each 8 months that we meet, I feel there is our thinking around these problems becomes a bit more focused, and these things happen slowly, but they happen surely. So anyway, so any other thoughts someone would like to add? Some of the colleagues or maybe people who are not colleagues in the sessions.
I mean, I think on the data side, John and I and others have struggled with this. We have to do something. Let's say to start with healthcare, and the fact that we have massive stores of data, like the Veterans Administration data, that it's really hard to get access to without just hard to get access to, and there has to be a way to reduce restrictions while preserving various privacy constraints. And then with curation, I mean, the National Library of Medicine has a bunch of efforts to do for data what they did with medical literature, with PubMed, with hosting data sets of various kinds. And there's a big discussion going on there. I'm on the Board of Regents. But we have to sort of, as a nation and as scientists and as the world, figure out ways to get access, to make access to rich representative data sets in different fields. We're really in the dark ages right now, as much as we've tried. I mean, it's been nice to know that there's been some legislation around electronic healthcare record systems not providing interfaces or locking their data into one system. At least that's coming to the fore with some interfaces coming to exist now. But we're still way back in the dark ages, given where we could be with this.
Yeah, I think right now, as we look at COVID-19, there's going to be some great opportunities. So for example, MIT, when they bring back the students, are going to require testing. And it would be nice if we could get out ahead of it and have as many students as possible sign waivers that would let that data be available for research, right? A lot of data is about to get collected. Now, the risk, of course, it will be like psychology, right? All of psychology is the psychology of undergraduate, because you have good access to those. And maybe we could have the same problem here. But data is about to get collected that we've never collected before about healthcare data. about contacts and everything else, it could be incredibly useful. Or we could collect it and then just find ourselves right where we are now with everything else that we can't use it. And it would be nice if somehow people could get out of ahead on that. So I think, Alexander, you should use your status as an important person at MIT to get them to do the right thing.
Am I an important person at MIT? Okay, that's good to know. It's that's definitely good news. No, but like honestly, like, but it is, you know, like this is the funny thing is that like I was thinking about something similar, and like, but like it makes you pause, right? Like, because you know you don't know, like, you know, there is no way to perfectly anonymize this data, like, because if you perfectly anonymize it, it will not be useful to you. And kind of these are our undergrads, you know, like, and like, you know, there is like, it's actually funny, like that I'm often aghast by, like, I would say privacy practices of my students. Like, they just don't use passwords even for their laptops, and they're like super open about stuff. But then you know that this is not the right approach in the current age. So kind of, even if they would sign such a waiver, I'm not sure if I want them to sign it. So, but yeah, the good thing is that there is a, you know, like, even when I talk to like people in the government, there is a lot of understanding that more data openly available would be a good thing. And you know, like, yeah, so there's a lot of data. Like, essentially, there are two entities that have data: industry and the government. You know, there are the two entities that have a lot of data. And while industry, we are working on this, and you know, like, they have their reasons why they don't want to share the data. And I think they would be okay sharing with researchers, but they don't want their competitors to see the data. So that's the problem there. With government, of course, the problem is, you know, mostly about, like, you know, secrecy and about regulations. Yes, and I think there is a willingness to at least loosen up the regulation things. I think it's, as long as we often enough, you know, explain what is the importance of this, I think there are kind of listening to us, you know, like,
Right.
we will see what, and we will see what will be possible.
Well, I would say that there's an opportunity here with the pressures of the pandemic in healthcare, but in other places, to think through what would be appropriate legislation to address some pain points with data access. And it's up to our community as computer scientists and passionate biomedical informaticists and other related domains to figure out how to technically address some of the concerns, let's say with privacy or the identification and so on, and how to grapple with HIPAA laws, and maybe they should be changed. But I think it's a really great opportunity area for us to actually move forward and think about, well, as technologists, maybe with a little bit of policy ability, if we had our way with, like, you know, recommendations to Congress for what should be done to change things, what do we say, and what technologies would be enabling for the pain points?
Yes, so let me be a bit contrarian here. Like, in some ways, unfortunately, even though much of the problem with COVID is, you know, lack of data and bias in data and so on, I'm not sure we have yet made a convincing story of, like, oh, if only we had all this data, it would be all different. So definitely people, like, you know, they got, like, the spotlight is definitely on, like, healthcare and public health. But like, I think it still remains for us to really show the power of what you can do if we only had data scale. For instance, it's not that there is a data that's not available to us. There is no data, period. Again, this is actually changing. So I'm in some collaboration where finally we managed to get hold of, like, a large chunk of data, and it took ages to get access to it. But like, I think now the point would be, and that's hopefully what we will be doing, is let's show the world what could we have done about COVID, or what we will be able to do about COVID with the data that is out there right now, because I think this is still missing.
Yeah. Well, Alex, you know, as we open up, like MIT or Berkeley or cities that have different public health policy programs of various kinds, the prediction of the following form is, like, if you're counterfactual, take person X and do COVID positive. What happens to them? We don't know that answer yet. And you'd need to know a good answer to that question, I think, to do good, finer-grained public health programs to open up the economy. So I think that we can imagine how data could be applied in very powerful ways.
No, like, I totally agree, but like, we have to do this now. Like, we have to show how you can leverage data to do exactly these kind of things. So now it's our time to shine, you know.
Yeah, and we've seen some examples like we're working with some NYU folks at Longhorn, one of the epicenters where they had thousands of patients, our team. And that team has built some really beautiful predictive models for like, this patient will need oxygen of the form they can't get at home, admit them. This patient will not have an adverse outcome for 96 hours. They can go home with observation to minimize some of the strain on the system there. And, you know, quite good performance those models have, looking at many variables and even discovering, oh, we can use 3 variables and we get most of the accuracy out. So those, we always see, you know, great, you know, strong applications of machine learning and helping out, you know, with figuring out how to do triage and preparation.
Yes. So I agree. So I guess this is the, you know, the good point to stop today's day is I think, you know, there are great opportunities, you know, and, you know, I know that many of us already are involved into this, but like, yeah, I hope that, you know, there will be like these great outcomes and this new empowering tool that will kind of help to make the case why, you know, responsibly used, you know, and reliable machine learning is actually something that can make the world a better place. You know, just to say. But yeah, for now, let's just close off this day. And, you know, tomorrow we start again at the same hour. We have another keynote by Hall. And then we have, you know, 5 more lightning talks, and we have 2 more parallel breakout session, and, you know, and then we can close off the day tomorrow. So thank you so much for participating. Actually, like, I really enjoyed the whole day. I learned a lot, and I actually even met some new people. So so see you soon.
Bye-bye.
Thanks, Alex. Thank you.
Very much.
See you.
Everybody,
Everyone.
see
Thank you.
you.
Bye-bye.
Bye, everybody.